All right, everyone. How are you? I apologize ahead of time about the length of time that this video might take us today because it's a little bit of a longer concept. I want to make sure I kind of explain it properly, and I'm also going to try to do it in one go. We'll see if I make it. So today what we're going to be doing is we're going to be doing simultaneous equations. We're going to do 3 different ways of doing simultaneous equations. The first way we're going to be looking at this is the graphical method. I think my daughter has lost her tooth. All right, so in this, in linear, I'll try to talk and write at the same time, in linear equations, with one unknown, usually, come on there, usually there is one unique solution. For example, in the equation, in the equation 2x plus 3 equals 7, there's only one solution. The value of x equals 2. Let me redraw that 2 so it looks more like a 2 and less like a z. X equals 2 is the solution. Okay, so that's kind of where we're going to start. If you're kind of trying to catch up to me, just pause the video because I'm just going to change the slide and kind of keep going. Let's see if I can just do this. No, I can't. Oh, I was hoping I could just kind of add another one. Here we go. So if we were to look at how to prove that or how to verify if that's true, what you can do is you take your original equation. So we would have 2x plus 3 equals 7. And to verify if this is true, we would substitute in we'd substitute in our value of 2. So we would write 2. Substitute in my value for x as 2 plus 3 equals 7. So then I go a little bit further. What's 2 times 2 equal? It equals 4 plus 3 equals 7. And then finally 4 plus 3 is 7. And you can see that this is obviously true because 7 equals 7. So therefore, and don't forget the 3 dots, that means therefore, therefore the value x equals 2 satisfies 2x plus 3 equals 7 to be true. So that kind of is a way to double check that everything is correct. I wish there was an easier way to kind of create these slides, but I'm just going to keep going. So if given the linear equation if given the linear equation 2x plus 3y equals 12, we now have two pronumerals in it. We've got x and y, so we have two pronumerals. It changes things. It has two variables or pronumerals. And as a result, has an infinite number. As a result, has an infinite number of possible solutions. Each solution is a pair . Is a pair of x and y values. You would call this a ordered pair usually, like x comma y. We write the x first and the y second. And that these x and y values make the equation true. So I'll give you some examples. So I'm just going to add another slide. Oops, typing the wrong words here. Canvas. My computer's going to stop working now. Great. Give it a second here. Oh, there we go. Looks like we're back on track. All right, fantastic. I was ready to crash my computer. So if we still have our same equation, so I'll still use 2x plus 3y equals 12. There's a number of possible solutions that could make this equation true. One example would be x equals 0 and y equals 4. Another possible solution would be x equals 3 and y equals 2. Another example would be x equals 4 and 1/2 and y equals 1 are all examples of possible solutions. When we talk about these possible solutions, the other thing to note or to remember from year 8 is that these are both making something called an ordered pair. So these are examples. Same thing with them here too. Examples of ordered pairs. Example of ordered pairs. Usually the ordered pair is written in the order of x comma y. If I were to write this above example as an ordered pair, it'd be written as 0 comma 4. If I were to write this ordered pair as an ordered pair, I'd write bracket 3 comma 2 close bracket. You always use brackets and you always use comma, and then you'd also use here would be 4 and 1/2 comma 1 close bracket. So you make sure you use brackets and a comma to separate your x and y. Remember that the x term is always first and the y term is always second in an ordered pair. If you want to think of it this way, here's where we can get really crazy. If I went to a graphing program, oh, I really think I'm going to crash this puppy today. Oh, here we go. If I were to look at an actual graph of this, and let me just type in our example that I just gave you really quick. That was 2x plus 3y equals 12. So every point that lies on this line, so I believe we had, I was trying to think of some of the solutions I gave you. I believe one was 2x plus 3y equals 12. I'm suddenly doubting myself. Wait, that was 3. Yes, there we go. So when x equals 3, And every single point you see on this line that I'm getting, even the ones with decimals, are a valid solution. So you can see just how many possible solutions there are for this question. Each time I get a stopover number, if there's a decimal, that's a possible solution that does satisfy this question. So I just thought I'd give you a way of kind of visualizing that there is truly an infinite number of possible solutions for this. And then if I zoom out, we can keep visualizing that, as we zoom out, each end of this line extends toward a positive and negative infinity, and every single point you see on this line represents a possible solution. So there are truly an infinite amount of solutions when you have two variables in your linear equation. I'm going to stop right there. I'm going to let you kind of absorb all that, and then I'm going to get into kind of the examples next. All right.